On this RAM 2500 HD with the 6.4HEMI P0351 is for the ignition coil 1 primary circuit. In plain terms, the PCM may be seeing a problem on the primary control side of that coil circuit. The driver may notice a check engine light, and the engine may run rough, misfire, or feel unstable depending on when the fault is active. The broad fault areas can include coil power feed, the coil control circuit, the ignition coil connection quality, or the PCM driver. The coil primary winding is supplied 12 volts from the fused ASD relay output circuit. This monitor runs continuously with the ignition on, and the code sets when the PCM detects ignition coil 1 signal circuit current less than or equal to 0 amps for at least 1-2 seconds. Before going into the pinpoint checks, start with the basic pre-diagnostic checks. Start by reading codes in all ECUs and recording the related data. Save the scan report and the recorded information so you know the exact conditions the fault showed up under. Clear all codes, turn the ignition off for a minimum of 10 seconds, then turn the ignition back on. Reproduce the operating conditions using the recorded data, then read the codes again. If P0351 does not return, treat it as an intermittent condition. If it does return, keep going. Next, look at the recorded codes for any ASD-related faults. If an ASD fault is present, diagnose that first. If there are no ASD faults, move into the coil circuit testing. Now load test the relay output power supply circuit at the ignition coil 1 connector. Disconnect the ignition coil 1 harness connector so you can access the power supply circuit. Connect the positive side of the load test tool to the power supply circuit at the coil connector, and connect the negative side to battery ground or chassis ground. Make sure the circuit is actually being powered while you test it. If it is an ignition feed, the ignition needs to be on. If it is a relay output, the relay needs to be energized and on. A good circuit should light the load test bulb bright, close to what you see with a direct battery connection. To be certain, voltage drop the circuit across the 3156 bulb. A 12-volt test light can be used only if it draws enough current to load the circuit. Many high-impedance test lights draw less than 0.1 amps, and that is not reliable for this check. The tool should draw more than approximately 0.75 amps for a proper load test. If the bulb is bright, continue. If it is not bright, repair the power supply circuit for an open or high resistance. Then verify the repair and confirm the code stays gone. Next, check the ignition coil 1 control circuit operation. Use a 12-volt test light connected to a 12-volt source and probe the coil 1 control circuit at the ignition coil harness connector. Crank the engine for 5 seconds while watching the test light. Be careful around a running or cranking engine. Do not stand in line with the fan. Keep hands away from pulleys, belts, and the fan, and do not wear loose clothing. If the test light blinks brightly while cranking, the control circuit is being driven and the next check is the spark plug condition. If the light stays on constantly, go after a short to ground on the control circuit. If the light stays off constantly, check the control circuit for an open or high resistance. When the control circuit gives a bright blinking signal, turn the ignition off and remove the related spark plug or plugs. Inspect for cracks, carbon tracking, foreign material, gap size out of specifications, and a loose or broken electrode. If any of those conditions are present, replace the spark plug. If carbon tracking is on the spark plug, inspect the ignition coil boot for damage and replace the boot if needed. Then verify the repair and confirm the code stays gone. If none of those spark plug conditions are present, replace the ignition coil and spark plug. Then verify the repair and confirm the code stays gone. If the test light stayed on constantly during cranking, isolate the ignition coil 1 control circuit and check it for a short to ground. Turn the ignition off, disconnect the ignition coil 1 harness connector, and disconnect the PCM harness connector. Check continuity between ground and the control circuit at the ignition coil 1 connector. If there is continuity to ground, repair the control circuit for a short to ground. Use the wiring diagram to trace the circuit and use any inline connectors to help narrow down the short location. Then verify the repair and confirm the code stays gone. If there is no continuity to ground, continue to the coil and PCM driver isolation step. If the test light stayed off constantly during cranking, isolate the ignition coil 1 control circuit and check it for an open or high resistance. Turn the ignition off, disconnect the ignition coil 1 connector, and disconnect the PCM connector. Do not probe the PCM harness connectors. Probing those terminals can damage them and create a poor terminal-to-pin connection. Use the GPEC diagnostic adapter for this test. The adapter can add up to 1.5 ohms of resistance to the circuit, so keep that in mind. Measure the resistance of the control circuit between the ignition coil 1 harness connector and the PCM harness connector. If resistance is below 3.0 ohms, continue to the coil and PCM driver isolation step. If resistance is not below 3.0 ohms, repair the control circuit for an open or high resistance, then verify the repair and confirm the code stays gone. Before condemning the PCM, determine whether the ignition coil caused a PCM coil driver failure. An internally shorted or damaged secondary coil circuit may be the reason the driver failed, so do not replace the PCM until this is checked. Remove the ignition coil controlled by the driver that's set P0351 and install that coil in another coil location that did not have a fault set against it. Turn the ignition on, clear the codes, then start and run the engine for up to 1 minute. If the engine will not start, crank it 3 times for 10 seconds. Then read the codes. If a correlating fault sets for the new coil location, replace the ignition coil, replace and program the PCM, and verify the repair and confirm the code stays gone. If the fault does not follow to the new coil location, continue with connection checks. For the final path, apply any service bulletins that fit the vehicle and fault. Then disconnect the PCM connectors, any related inline harness connectors if equipped, and the related component connectors. Inspect the connectors and terminals for proper seating, damaged locks, corrosion, water intrusion, seal damage, bent terminals, overheating from poor connection, terminals pushed back in the cavity, spread terminals and terminal tension. Repair anything you find. Reconnect every connector fully and make sure the locks are engaged. Clear the codes. Test drive or operate the vehicle under the conditions that run and set the fault, and read the codes again. If P0351 returns after those checks, replace and program the PCM, then verify the repair and confirm the code stays gone. If P0351 does not return, the wiring or poor connection problem has been repaired. The takeaway is simple. Prove power, prove the control circuit behavior, inspect the plug and coil path, and only make a PCM call after the wiring, connections, and coil check supported. For more diagnostic training, visit stepdiagnostics.com.